Okay, so we're back with chapter 10, part 1, ellipses. And I want to talk about, again, the standard form of an equation. And in this example, we're going to be finding standard form given some information. So let's first talk about standard form. So standard form of an equation, just like we did with circles, we're going to read the center is going to go here. So the notice again that these are negative, so it's going to be the opposite of the center. So this is going to be the ellipse is centered at HK, essentially, right? This is the distance we go from the center in the x direction. This is the distance we go from the center in the y direction. Now, without actually looking at the points that we're given, we don't know if this should be B or A. We don't know if this should be B or A, because remember, the bigger one, right, the major axis is always the bigger one, so the bigger one's going to be A. And they've already figured it out, right, but we're going to figure it out. So they've written it this way because they've already figured out that this is going to be A. But we are going to go through the process of figuring that out. So the bigger one is going to be your major axis. And so if the bigger number is here, then that is an ellipse that is longer, right, in the y direction. If this were the A, then that would be an ellipse that's longer in the x direction. All right, this is always going to be 1. The standard form, this is always going to be 1. If this is ever a number other than 1, divide by that number, because that's going to change your A and your B. So you need to know what that is. This needs to be 1 in order for these to be the squares of the major and minor axes. So this needs to be 1. If it's not, make it 1. All right. So this has to be 1. So this is our setup. So let's look at what information we're given. So we're given the vertices and the foci. All right, we're given the vertices and the foci. So what I would do is I would plot these to try to get an idea. Like, it doesn't have to be perfect, but I would plot them to get an idea of what I'm looking at. I always find it easier if I can see it. Okay, so my first one is at -2, -8. So I'm going to put that there. And then I have another vertex at -2, +2. So that's here. And then I have foci at -2, -7. And -2, 1. Okay, so observation. The foci are always along the major axis. So since these are all in line, that tells us that this is our major axis is in the y direction. So we were told that these are the vertices and these are the foci. And so those are always going to be all in line. The vertices and the foci are going to be all in line. And so since they're straight up and down from each other, that tells us that our major axis is in the y direction. So I would agree. We would need to put A here. This is going to be our bigger number because it's this line, right, is in the y direction. If we were given vertices and foci and they were in line in the x direction, then that would be our major axis. We could be given any number of things. They could have given us the vertices and the covertices. They could have given us the covertices and the foci. They could give us any combination of things. We just need to use the information that we're given, right, to figure out A, B, AB in the center are what we need. Now we're going to find C because we're going to be using C to find B in this case. And I'll show you why in a second, but we don't need to know C to write our equation. We're just going to have to find it in order to find B. Okay, so first of all, let's find our center because that's going to be the easiest thing because the center is going to be halfway between the two vertices or halfway between the two foci. Either one, doesn't really matter. So we're going to find the midpoint between the two vertices. So if we remember how to find midpoint, we're just going to average, right? We're going to average. We don't need to average the x coordinates because they're the same. So we would just get -2. That's not necessary. So we know that our center, all right, center. We know that our center is going to be at -2 because it's going to be in line with the rest of these, right? We know that the center is going to be at -2. Then we can take the average of -8 and +2, or we could take the average of -7 and 1. It doesn't matter. Because either way, it's going to be halfway in between. So -8 plus 2 is -6. -6 divided by 3 is -2. And if you want to check to make sure that you did that correctly, why did I divide by 3? I should divide it by 2. I didn't do that correctly. -6 divided by 2 is -3. I don't know why I divided by 3. Oops. So sorry for being confusing. -6 divided by 2 is -3. And you can check that by saying, okay, to get from -3 to +2 is 5, and to get from -3 to -8 is also 5. So that is in fact halfway in between, so that's good. Yeah, I don't know where that was weird. I don't know where -2 came from. All right, so this is our center, -2, -3. So we found our center, and they also found the center. They also averaged the vertices. They averaged both of them. I just decided this one was obvious, so I didn't do that. So this is our center. Now we need A and B. So A is going to be the distance from the center to a vertex. Either one, doesn't matter. It's the same, right? It's the distance from the center to a vertex. So A, in this case, I just said it a few minutes ago, is 5, right? So I could say, okay, I need the -3 to 2, right? Distance from the center to a vertex, or -3 to -8. So I could say that's 2 minus -3, right? Or -3 minus -8 would be another way to do that. So that's going to be 5. So A is 5. A equals 5. All right. So we have 5. We have A. Again, distance from the center to the vertex. Now we know that A squared equals B squared plus C squared. We learned that in the last video, and I talked about why that is. I need to find B. I don't know anything about B except this, right? But I can find C. I have A already, I did that. And I can find C because I know where the foci are. Right? So C is the distance from the foci, or a focus, to the center. Okay? Distance from a focus to the center. So C is going to be the distance from -3 to 1 or -3 to 7. So I'm going to do -3 to 1. So it's 1 minus -3 is 4. Okay? So C is 4. All right, and I'm just going to rearrange this to solve for B. So I'm going to subtract C from both sides. So I have B squared equals A squared minus C squared. Okay, so I have B squared equals 25 minus 16. 25 minus 16 is 9. So B squared equals 9. So B equals 3. We're talking distances here, so positive, negative doesn't matter. A, B, and C always going to be positive. So you might have recognized before I finished this, right, that A was 5 and C was 4. So you might have recognized that as two parts of a Pythagorean triple. So you may have been able to realize that B was 3 without even doing the calculations. If you recognize that, that's great. If not, the calculations always work. So this is, right, it's a 3, 4, 5 triangle, with 5 being the hypotenuse. So A is the hypotenuse in this case. So as long as you keep that in mind, if it turns out to be a Pythagorean triple, you don't even have to do this part. All right, so we have A, we have B, we have the center. So let's go ahead and write our equation. So our equation is going to look like this. So we're going to have x minus the x value in the center. So that's going to be x plus 2 squared over, this is going to be b squared. So because the minor axis is in the x direction, b squared goes under the x term. So b is 3, so b squared is 9, so this is going to be 9. Technically, I didn't even have to figure out what that b was 3 because all I really need is b squared. But anyway, plus y minus the y part of the center, so y minus -3, so y plus 3 squared over a squared, because the major axis is in the y direction, so we need a squared. So a was 5, so a squared is 25, and all of that is always going to equal 1. So that's our equation, okay? So we have the center, the major, half the major axis squared, half the minor axis squared. Notice I said half there. So this is so A and B, this is separate topic from writing the equation. We've done that part. The major axis, right, goes from vertex to vertex. A goes from center to vertex. So if I ever wanted to know the length of the major axis, that would be A times 2, right? Because it goes from center to vertex and then center to vertex. So that'd be A times 2. So the major axis in this case would be 10. And then the minor axis, same deal. The minor axis would be 6. So if you ever have a question that asks you for the length of the major axis, like the minor axis, or gives you the length of the major axis and the major or the minor axis, and asks you to find something else, right? Like the equation, they can do that. Remember that that's 2a or 2b, right? So that's just something to bear in mind if that's what you're given, right? Because it's easy to say, oh, the major, like if it says the major axis is 10, it's easy to be like, okay, A is 10. No, A is 5. So that's just something to bear in mind. Okay, so that's all I'm going to do for this video. In the next video, we're going to be graphing. So we're going to have the equation and we're going to be graphing it. So I will see you in the next video.